So we'll discuss another four link mechanism. So in the four link mechanism, here you have to determine torque to applied on link 2. So here AD is 50 mm, AB is 40 mm, BC is 100 mm, TC is 75 mm, and DE is 35 mm. So here first analyze the forces acting on each link. So AB, if you take the line of action of force that is going to act is F of 1, 2. So at point at joint B, line of action of F3 of 2 it comes. So with respect to link BC, if you take, so line of action is F2 of 3. Line of action at joint C is 4 of 3 it comes. So if you take the torque acting on the link 2, here it is F of E, it is going to be at the center. So here at D f of 1 4 it will be applied, and line of action of f of 3 4 will be there. So like this 1 2 3 links are analyzed with the forces. So for this what you have to determine is torque 2 must be calculated. So construct the required triangles so that you'll be able to determine the required couples. So the procedure remains the same what it has been solved to the previous problem. So construct the couple diagram with respect to the known forces so that you'll be able to get the unknown forces. So if you take another problem with the same slider crack mechanism, but the input values are slightly varied. So here once again you are supposed to determine the couple T2 which is going to act on the link 2. So here additional force of Fc 1000 Newton it is added, which is at the inclination of 50 degree. So AC has got the length of 70 mm, AB is 150 mm, O2 and A it is at a distance of 40 mm. So here if you analyze the forces, so with respect to link 2, here it is O2 at point O2 force F of 1 2 will be there. At joint A, F3 of 2 will be there. So if you take the inclined force Fc, it is F2 of 3. F2 of 3 force must be compensated, and the vertical force is F4 of 3 will be acting. So if you take the piston, there are two forces. One is F3 of 4 and F1 of 4 will be going to act. So here the torque T2 is equal to F3 of 2 into H you are supposed to take. So here that is also equal to F1 of 2 into H, both we can take. So here by taking a suitable scale, once if it is constructed and calculate the value, you'll be able to know the forces acting on that, and you'll be able to compute the value. So here F3 of 2 and F1 of 2 form a counterclockwise couple, and T2 acts as a clockwise in the clockwise direction it is going to act. So determine the torque to required to keep the given mechanism linked. So once again torque 2 comes. So it's a 4 bar mechanism. So O2 of A is 30 mm. AB is AB is equal to O4 of B, and O2 to O4 it is 60 mm. AO2 O4 it is at 60 degree. BC it's at 19 mm. AD is at 15 mm. So analyze the forces. So O2 of A, the forces are F1 of 2 and F3 of 2 it comes. Next link 3 is F2 of 3 and F4 of 3 it comes. So there will be an inclined load of 500 meters for that. So if you take with respect to link 4, there is an inclined load of P. So F3 of 4 and F1 of 4 is going to act. So P is equal to 200 Newton. So here none of the links are acted upon by only so here none of the links are be acted by only two forces. So there are only two links. So links can't be analyzed individually. So here as the two forces are applied with respect to two link, we cannot, unless we expect only one force on one link so that we'll be able to analyze.